All right, hello, welcome everyone. Take your seats. Also close the outlet door back there so the AC is working. Well, when people finish coming in, please close the outlet door back there. Thank you. We'll figure it out. All right, so this is Dionysis. He's going to talk about how NixOS is built from PR to your local Nix store. Take the word.
Thank you. Hello, everyone. First things first, this QR code is going to take you to the slides if you prefer viewing it in your phone. Before I get started, I would like to thank the organizers and all the volunteers for making NixCon possible. My name is Dionysis Grigoropoulos. Online, I go by Grigoropoulos, depending on the context. On GitHub, you can find me as Erethon. On email and Matrix, you can find me as Dgrig. I'm an SRE by trade, but I'm a hacker at heart. I like tinkering with electronics, anything that has to do with infrastructure. I believe in self-hosting, and I'm part of a group that promotes self-hosting. And I enjoy looking for security bugs in software. Today, I'll be speaking about the building blocks for building NixOS. This includes all the infrastructure, the tooling, the automations, and the dev repositories involved. The goal is by the end of this presentation to know where and how cache.nixos.org is hosted, where packages are built, how they are placed in the cache, how they are signed, and how the sources of the packages is managed and reviewed. I think it's important to note that none of this is magic. All of this information is currently public in our Git repositories. Anyone can figure this out. I'm new to NixOS myself. I've only been using NixOS for a year and a half. The way I figured these things out is by Git cloning the repositories and greping at the source code. So, binary caches. A core feature of Nix is its ability to reuse packages from another store location. Looking at the man page for nix.conf, we see that there is an option called substitutors, which allows us to specify one or more stores from which to pull store objects. That is without building them from source. If this setting is left empty, Nix will build everything from source, effectively turning NixOS into a source-based distribution. Out of interest, is there anyone in here that builds the system this way, only using source code? No? Okay, 1 hand, 2 hands, 3 hands, okay. I've tried it myself, I've run into some issues, I would love talking with you after this talk. The default configuration for NixOS puts in etc nix.conf a substitutor for cache.nixos.org. So for the rest of this presentation, we're going to figure out where this is hosted. When trying to understand how a project is structured, I like to approach things from a bottom-up perspective. As such, I think it makes sense to start with the domain name for nixos.org. Running a whiz query on nixos.org, we see that it's registered in Gandhi. Gandhi is a French company that provides services for domain hosting and web hosting. Next, we can take a look at the name servers for nixos.org. Again, we see we're using the Gandhi name servers. And finally, we can take a look at the A record for cache.nixos.org, and we see that it points to a Fastly domain currently. All of this information is managed in the infra repository under GitHub NixOS infra on the DNS directory, and it's using DNS control. DNS control is an opinionated software for management of DNS records. The configuration for it might look something like this. I've omitted a lot of the steps, but it's just plain JavaScript files, and they specify the DNS zone. We said that cache.nixos.org currently points to fastly.net, to a Fastly domain. Fastly is a company that provides CDN services, content delivery network services, and this is how we're using them. They have more than 80 points of presence in major cities around the world. So when we're doing a pull from cache.nixos.org, we're pulling from the latest server closest to our location. Fastly currently serves the landing page, the nar info, and the compressed nar files of packages. And besides being used for cache.nixos.org, it's also used for the artifacts, for the channels, for the releases, and for the tarbles. The Fastly configuration is, again, in the infra repository under NixOS infra, on the Terraform directory under cache.tf. It's managed using Terraform and OpenTofu, which are software used to manage cloud and physical infrastructure. It's very easy to learn both OpenTofu and Terraform if you want to look at it. I mentioned that Fastly is only used as the CDN. This is because Fastly only serves the NixOS cache content. It doesn't store it long term. For that, we use Amazon Web Services S3. S3 is an object storage service. And Fastly uses that as the backend for getting the packages it hasn't already cached. As of early August, the S3 cache is at over 700 terabytes in size, and it's growing at a rate of about a terabyte per day. This currently costs, I think, $15,000 per month, and Amazon is sponsoring it. Again, the code for this is using Terraform. It's in the same file as the Fastly one. And here's a simple architecture diagram of what this might look like, of what we discussed so far. On the right-hand side, we have Gandhi for DNS. And on the left-hand side, we have cache.nixos.org, which is being served by Fastly, which in turn uses S3 as the backend. Pretty simple architecture. So far, we've identified 3 companies that we're using to get, that are in the hot path to get packages: Amazon, Fastly, and Gandhi. So the question becomes, do we trust them? Do we have to trust them in order to use the cache? And the answer is no, because Nix, by default, or one of the options that Nix has, is the ability to check for cryptographic signature of the packages that we get, and make sure that they are signed by a private key, and if we have the same public key, we can verify that no one has tampered with them. So not Gandhi, not Fastly, or not Amazon. And this is the default configuration for nixos.conf. We have a public key for cache nixos.org. As Arjen said yesterday, this hasn't been rotated in, I think, 10 years, but there's work being done on allowing multiple signatures on a package now to be able to rotate this key. It is important to note, however, that we bootstrap our trust over these companies. When we first download the ISO, all the information we have for the ISO is coming from Fastly. And now that we've seen how the cache is set up, let's take a look at the tool that builds the packages and puts them into the cache. This tool is Hydra, the NixOS CI. It is a Perl-based continuous integration system. I think it's over 15 years old at this point. It's obviously being developed still. It started 15 years ago. It runs the NixOS test, it builds packages, it signs them, and uploads them to the cache. But this happens only after they have been merged into Nixpkgs. It doesn't do it before, it doesn't do it on PRs. Hydra, the software, has a flake and a module. It's very easy to set up and run it if you want to experiment yourselves. I've done it. It gave me a better perspective of how the upstream project works, because it's very easy to set up and play around with it. However, I understand that it's difficult to scale up, at least to Nixpkgs scale. I haven't done that. And it currently builds more projects than just Nixpkgs. The official installation of Hydra on hydra.nixos.org currently consists of one coordinator node and one database node, 2 x86 Linux builders and 2 ARM64 Linux builders, and 7 Darwin builder nodes, 5 M1 Max and 2 M2 Max. The coordinator, the database, the Linux builders, and the M1 Darwin builders are hosted in Hetzner. Hetzner is a German company that specializes in cloud infrastructure and dedicated servers. And the M2 Max are hosted in OakHost. If you listened to the State of the Union talk yesterday, MiG92 mentioned that the Hydra builders were migrated to Hetzner at the end of 2024. Before that, they were hosted in another company. And this is what the Hydra architecture looks like with what we've seen so far. We see that the builders are connecting to the coordinator node, which takes the build packages, signs them, and then pushes them to AWS 3 using the S3 API. Since these are the machines that build the packages and the coordinator node takes them and signs them, everything that's on the left-hand side of this is trusted because it's what builds and what ends up building what ends up in the cache. So all of them are inherently trusted. So now that we've seen how the packages are built and signed, we can move on to see where the source code for all of this is defined. This is GitHub. GitHub is hosting all of the NixOS repositories. It has all the issues, all the pull requests. The Nixpkgs repository at the moment has about 8,800 open issues and 7,800 open pull requests. In comparison, this time last year, we had about 6,100 open pull requests. And we make heavy use of GitHub Actions. So since late 2024, we moved to GitHub Actions for CI of Nixpkgs and evaluating the Nixpkgs pull requests. Since then, a lot of new GitHub additions, a lot of GitHub Actions have been added that help automate the processes around PRs and review and merges. For example, example actions might be the periodic labeling of PRs. When someone opens a new PR, it adds an action runs on a time schedule and adds labels. It might add the needs reviewer label. It might remove it when someone reviews the PR, all these things. Another action might run linting. Another action will run Nixpkgs event, might ping maintainers for packages they maintain, will run the evaluation. And all of these actions use Casix, which is a company that provides remote Nixcases. And they're using it as a certcast to make builds faster. And as for the numbers, during the month of July, the actions for Nixpkgs ran for about 900,000 minutes. If we do the math, this comes out to 625 days. And just for Nixpkgs, this costs around $13,000 per month, which is sponsored by GitHub. And expanding on the previous architecture diagram, this is, if we add now GitHub on the mix, we see the Hydra coordinator is pulling the latest changes from GitHub. Meanwhile, GitHub Actions have a feedback loop with a Nixpkgs repository, resulting in less manual steps needed for a review because something happens in a pull request, a GitHub Action runs, updates the labels or whatever, so it saves us time. The Casix is connected with GitHub Actions, and it's only there to be used by GitHub Actions. There is a comment in the Nixpkgs code that uses the Casix that no one else should use it because it's not trusted. It contains things that were added during PR review, so it's not approved by someone. Since the Nixpkgs repository is our source of truth, we do trust GitHub with what ends up in Hydra and the cache. Finally, I did mention that Hydra builds and runs NixOS tests after a PR has been merged. However, it's often useful to build packages and run tests during PR review. This is done by Offborg. Offborg used to be the main CI for Nixpkgs, but since most checks have moved to GitHub Actions at the end of 2024, it's now only used for package build and NixOS tests. It will automatically build packages when the PR title follows a specific naming scheme. Otherwise, you can ping Offborg manually via GitHub comment to run tests or build a package. The infrastructure for Offborg is currently 3 x86 and 2 ARM64 Darwin hosts, 5 Linux builders, 1 core coordinator node, and 4 evaluation hosts. The Darwin builders run in Mac Stadium, a company that provides Apple machines. The Linux builder run in tetaneutral.net, and the core host is hosted on Hetzner Cloud. No trust is placed on Offborg, since the build artifacts it generates aren't reused anywhere, so it's not trusted infrastructure for us. The conclusion of all of this is that currently we only have to trust the Hydra infrastructure and the people that have access to it, obviously, and the Nixpkgs source code hosted on GitHub. We don't have to trust anything else. It's easy to get involved in all of the above aspects of NixOS. As I say, usually fixing something is only pull request away. Improvements can be made anywhere. Don't be afraid to look at things or ask questions. And pretty much that's the whole overview of how NixOS is built. There's nothing else. So, any questions?
Thanks for the talk. I have 2 questions. Is Offborg also Hydra-based?
No, it's something else.
Ah.
Yeah, it's something else. I think it's Rust-based, and
okay.
it's under, I want to say, the NixOS organization, the repository. Yep.
And the other question is, you say you only need to trust
Yeah.
you only need to trust Nixpkgs, Hydra, the builds, because they're signed. But basically, yes, you need to trust the PRs that nothing bad flows into the thing.
Yeah,
right? I mean,
yeah, we obviously have, if we're trusting the source code, someone puts the code in there, like the PR, someone reviews it. It's only 250 people that are committers, I think, currently, that have access to merge to Nixpkgs. So technically, we trust those 250 people, but I think if something malicious was merged, someone else would also see it.
you can easily package maintainer, I think.
Sorry, come again?
It's easy probably to get a package maintainer and package something.
I can repeat it.
I repeat it. So
Yeah.
I think it's easy to get a package maintainer if you, let's say you have a Go package and you push it into Nixpkgs, somebody reviews it, you get a maintainer, and suddenly you basically also can review it.
Mm-hmm.
I have some packages and I'm constantly under the question is, I mean,
Yeah, you can get.
people need to trust me that I do the right thing. So yeah, it's kind of, maybe it's a wrong question for this talk. It's kind of a
You can get malicious code into Nixpkgs, I guess, if you want to. And maybe people won't catch it, but this doesn't affect the infrastructure because all of the builds are sandboxed. So even if you do something malicious during your build time, I don't think you can expand outwards in Hydra from there.
Could you expand on what off-borg brings that GitHub Actions doesn't, and why I would want to call it?
I think we can't do builds on GitHub Actions because it just takes too long. The same for tests. In the past, I think we couldn't run KVM workers in GitHub. Like you couldn't run NixOS tests in it. I think nowadays you can. I'm not sure.
Yeah, I guess I could also answer a little bit. I think with GitHub Actions, you can't easily get set up a Nix cache. Like you don't have a backing Nix store, so every time you run a GitHub Actions, you start with a fresh root directory effectively. And every single dependency you need to download. So multiply that by how many PRs times how many per day they get updated, and it turns into a huge cost for GitHub that I'm not sure if they would sponsor that, they might, but yeah, it's very expensive, I imagine.
And if I'm not mistaken, Sylvan is the person that did the original off-borg to GitHub Actions main switch back in 2024. Yes. Any other questions? Then, perfect, thank you.